Today I want to talk about binds in your car. And I'm not talking about binds that we would normally think like stuck rod ends and stuff like that. I'm talking about mechanical binds that are actually kind of designed into the car if you don't line up all your components in the right way. It'll cause a hiccup in the suspension and it won't allow it to roll. So let's roll the intro and we'll get into the binds in a race car. I've spent the last 30 plus years working on race cars, building race cars, and racing cars. And I'm here to help you better understand racing technology. I kind of got introduced to this thing years ago. I had worked with Darren Miller a little bit on a car that we built. If you don't know who Darren Miller was, if you've only been around the sport a little while, he was a dirt late model driver from Illinois. Really sharp guy, real quiet guy, and you had to watch what he was kind of doing because he wouldn't tell you everything. But I learned a lot from hanging around with him, and what he did tell me, it was priceless. So basically, what he did is we took the car and we put it basically at ride height, and he had me roll. The left rear was dropped, and he had me roll the right rear up and pick up on it, and he kind of felt some things and looked at some springs and shook the springs a little bit to see if they were loose or preloaded. He had a system. He really knew what he was doing here. But as I watched him more and more, I started looking at the car a little differently and actually seeing that there could be a bind in that left rear or the right rear as the car rolled. So I'll do a little sketch on this later on how this all affects the left rear. But binds in your car are a big deal. I think the first thing everybody needs to do is build themselves a couple of sets of ride height gauges. Ride height gauges, like what we used to do is we used to use some cheap little 065 electric weld tubing, real cheap, less than $1 a foot. If you can get it on a deal, usually it's less than 50 cents a foot. Really cheap stuff. You get yourself some half by half rod ends, lefts and rights, and you get double jam nuts for each rod end. You're going to need a left and a right for each rod. You're going to need 4 corners for each car. So what you want to do is you cut your ride height, you cut your tubing the approximate way, you thread your rods about halfway into your jam nuts, and then you tack weld your jam nut to the tube. So then you'll have almost like a tack welded radius rod where you can loosen your jam nuts up, you can adjust a little bit, but they initially should be welded close to what your ride height or your center to your center on a shock would be at ride height, all 4 corners around the car. The second set you're going to want to make is for a car at running attitude. You know, you want to compress your right rear a little bit. Left rear, usually you're hanging on the chain or on the rods or whatever you do. You're limited, you're all the way extended. So the second set you'd probably get by with 3 of them. Your left front and your right front, you're going to want to make those ride height gauges for both of those. This will help you when you're checking Ackerman, you're checking bump steer. These things are invaluable. So the first thing I think everybody needs to build for their cars are two sets of ride height fixtures, or gauges I call them, ride height deals. So how you want to check this thing is you want to let your left rear drop down all the way onto your limiter, whatever it may be. Put your ride height gauge in your right rear where ride height sits, and then have one person go to lift up that right rear and feel how smooth it is or how unsmooth it is through the transition. Watch that left rear, watch the spring. Something interesting will go on with that spring if stuff isn't lined up, and I'll go through that in a drawing later on the drawing board. But you're going to want to run that thing through the right rear motion that your car would see as it rolls over, and then swap spots. You know, if you were the lifter on the right side, have the guy that was watching the left rear, so you get more interaction use. Everybody can kind of talk about what's going on with that car. And I'll go through some things later on exactly what to look for and how to identify problems. We'll go through it on the drawing board. The last thing I'm going to go through is J-bars. I don't particularly like J-bars as a lateral locating link. I think there are much better ways of doing it, but with our rules the way they are, I think we're stuck on J-bars for quite a while. I don't think sanctioning bodies are going to let anybody be creative anymore and come up with new ideas to get traction. It almost looks like we're going to be on a 4-bar J-bar spring behind thing until these late models don't exist anymore. I mean, sanctioning bodies, in my opinion, are screwing up big time. I came into late model racing when it was a builder and a thinker's type of sport. I came from more of an open wheel sprint car deal, and I'd been doing late model stuff for a while. I had my own IMCA style modified and learned a lot from that. But then when I sold that, I was back into the sprint car thing. Then I went to Pennsboro one year, and it was the year that Marshall Green won the show over Freddie Smith. I think it was Freddie. But I called my wife after I got there for about a day, and I told her, sell all my sprint car t-shirts and all my stuff. I was a late model guy, because the stuff that was going on in late models was a builder and a thinker's deal. It's almost like it was the Wild West. Anything you could come up with to make traction, make your cars faster, people were doing. Sanctioning bodies didn't limit things like suspension. They went and looked at motor rules and tire rules and stuff like that, and traction control, which I'm against too. But the suspension realm was so wide open, and it thrilled me. I love dealing with suspension and looking for traction and understanding how cars work. One thing I do like J-bars for is a traction device. I think there is so much to be had with a J-bar in supplying traction. Not so good for a lateral device. I don't like them. I think there's better stuff. I actually think that I'm coming up with an idea recently about putting a leaf spring on the right rear, but still having a 4-bar on the left rear. But the problem is with the 4-bar, or the way you'd clamp a leaf spring on a right rear, you can't do it in the traditional method that you would do with the double U-bolts. This thing would have to pivot to allow that left rear forelink to come over and rear steer a little bit. But I think there is a lot of advantage to putting a leaf spring, at least on the right rear, if you can come up with a method of letting it pivot. I think there's three things, kind of theoretical, that everybody kind of needs to know. And then once you kind of get your mind working in a certain direction and you know this stuff, you don't need to apply it to your car and keep talking about it, but it conditions your mind into working in a certain direction. Those three things are the theory, the idea of a traction circle and how all that works, and then there's slip angle and slip ratio. Slip angle I've gone through in another video on front end stuff in Ackerman. I talk about slip angle a little bit, but today's video I think I'm going to draw a diagram, describe how the traction circle works and how to get your mind working on that deal. It's a trade-off. And then the idea of slip ratio we're going to talk about. And that's basically the same thing as slip angle, except for it's for traction. So we'll draw a video, or we'll draw a diagram about that, and we'll talk about that a little bit. Okay, I think the first thing we need to draw up here is the idea of traction circle. It's really old and it's really basic and nobody really talks about it, but I think it's important for everybody to understand how traction circle actually works. See, your tire only has so much traction built into it because of stretch. Either you're going to stretch the tire going forward, or you're going to stretch the tire laterally. Going forward, we call that slip ratio. Laterally, we call that slip angle. Side bite, slip angle. And the forward, the slip ratio, we call that traction, usually. But the idea of a traction circle is like this. You have a circle. This way here we have, let's say, lateral or turning or side bite. Side bite. Over here we would have acceleration or traction. Now your tire will have the most traction someplace on this circle in here and here. This would be like braking, and then over here would be like, I would guess like left turn, right turn, or something like that. This is how it was explained to me. Your tire will only have so much traction on the circle. It'll either be 100% turning or 100% side forward bite here. Anything in here, it's a trade-off between the two. If you want 100% acceleration, don't be trying to turn your car, because all it's going to do is push. If you're trying to turn your car and you're off the gas, don't try to hit the gas, because you won't have any stretch left for acceleration. The car will be real loose. So most of the time you're going to want to be in here. If your car, let's say, is broken traction, you're probably outside the traction circle here. This is your tire's optimum amount of traction is going to be right on that line. If you are on this line, you are getting the most from your tire. If you're inside the line, over here, you're probably not getting as much from your tire as you can. So you want to keep yourself basically on a line. And it's theoretical. I mean, where's the line? Maybe only Hoosier knows, you know, how much traction is built in for each way. But that's the feel of the driver, and what a driver will have and bring to the game is he'll start to feel when the car is broken traction. What he has to get in his mind is exactly where that tire and where he has to run that car so that he's not breaking traction and he's not underutilized traction. He has to get it in his mind kind of that there is a trade-off in tires. If he slides in on a slick portion of the track, he's going to want to be up here where there's more side bite and probably less acceleration in there until he gets the car slowed down enough to turn and then comes off. If he is pointed to come straight off the corner, you're going to want to be down here someplace. Maybe you're turning your car just a little bit, but you want all that traction you can. So the idea of traction circle is to get the most out of your tire and understand that there is a trade-off in the tire. Your tire can't do what it can't do. So if you ask too much, if you're at 100% turning full lock left, don't step on the gas. You know, if you're trying to step on the gas and you want to come off and drag race the guy off the corner, don't be turning left more than a couple degrees, if at all. In our dirt cars, probably if your car is set up right, you're always a little bit in a counter steer because of car yaw anyways. So that's the idea of traction circle. I think all drivers got to understand it, at least mentally. You never refer to it. There's no charts, there's nothing. But it's a good understanding that your tire will always have a trade-off. And if you get in a situation and you're trying to set up your line for the next corner, you know your slick spots are, you know where your mud is, you're going to want to put that car so that tire can get traction. If you know you're going to have to drag race somebody off the corner, make sure you maybe use a little bit of mud on the cushion to get your side bite, so then you can drive across the slick with 100% traction with the wheels straight to get as much traction out of your tire as you can. I think something that really needs to be defined better before we move any farther is the idea of slip ratio. In another one of my videos, I talked about slip angle and how slip angle, when you turn your tire, the tire gets stretched, and when the back of the tire comes off the ground or out of the contact patch, it snaps back and actually helps turn the car. Well, that's what we call side bite a lot of times. When you want to give sideward traction to your tire, it would be using almost like a slip angle theory. But now we're going to talk about forward traction and what they call slip ratio. Let's say you have a rear tire in your car. And we're going to draw, if I can get my pen to work. We're going to draw your rear tire here. Typically on a rear tire, you're going to have a contact patch. It'll be somewhere in here. That's what we think of as a contact patch. Now when your tire gets rotating, we'll draw a side view of a tire over here, the tire will rotate in this direction. What happens is the tire actually gets stretched. As it comes down here, it's free, and when it catches the road surface here, it'll actually get stretched, so you get a little bit of a bulge here. And then as it comes out of the back, it goes back into here. So your contact patch here actually moves forward. The center line of the tire might be here, but because of this bulge and because of this hitting the road, the tire's getting stretched through here. When it leaves the contact patch, somewhere through here, and it's all depending on what type of tire you run and everything else, it snaps back and propels the tire forward. So when you're looking at a top view from your tire, your contact patch is no longer in the center line of your axle. Your contact patch now moves forward and is probably somewhere up here. Your center line of your axle is here. So basically the snapping action, first you get your bulge in the front, and the snapping action of the tire leaving the ground or the contact patch is what pushes that tire forward. And that's what gives you traction. The more tire you can stretch up here, and the larger your contact patch will be because of stretch, the more traction you're going to have. That's also a difference between like mod tires and late model tires. Late model tires are very soft carcass tires. There's even some Hoosier different style tire that maybe some mod clubs run, that the carcass and the sidewall and everything is a little bit stretchier. This is not only the general bottom of the tire that's stretchy, but also your sidewall. A bigger sidewall will stretch more and give you more traction. It'll elongate your tire contact patch. It'll snap back harder and give you more forward bite. Okay, the next thing I wanted to show you is when we're talking about binds in our car, what I'm trying to discuss here is an actual mechanical bind. Now let's say your radius rods are here and they're hanging on the rod. So when you compress your right rear, your left rear, the distance it's spaced in here, if you think about this, pulling that up, your left rear, if this is your pivot, this will be like your pivot to your rear end, because your rear end can't drop any further than the rod if you're hanging on the rods. So when your right rear goes to compress, you're not only compressing the right rear spring, but you're compressing your left rear spring a little bit too. Even though there's no indexing happening anymore because your left is fully dropped, what you will be doing is the right rear is compressing and it's taking the left rear a little bit with it. Your right rear compression will basically be held up with your left rear spring just a little bit. Your spring rate on your right rear is dependent a little bit on your left rear. The further you get that left rear inward off the spacing here. So what I've always tried to do is get this left rear shock as close to here, so when you pick up your right rear, and you'll have a compression amount, a full compression on your right rear, how much you're going to want to run that thing, so you're not adding a ton of, compression to your left rear as the right rear tries to roll over. You can also do this with a limiting chain. Let's say your limiting chain is here. So your rods, your car now, will no longer hang on your rods. Your car will hang on a limiting chain. The closer this limiting chain is to the center of your shock, this acts as your pivot now. So as your rear end moves up, you'll have to have a little bit of play here in your rod. It won't be at full drop, so that when you compress this, your limiting chain becomes your pivot, and you don't index into that spring or compress into that spring with the right rear moving up, if you can get these points closer to lining up. This, I believe, is really important that you don't put any binds in your car. I've seen video and I've heard of people talk about when their car goes down the straightaway that it's lifting off the right rear spring, probably because there's probably some sort of a what I would call a bind or a misuse of the left rear a little bit over here. I think you always want to keep some spring tension on here and preloaded. That's why I loved left rear stack spring stuff, because you're always keeping a spring tension on here. But you don't want to start with the point where the right rear is being affected by the left rear spring also. You want that spring rate that you feel on your right rear to be the compression of the right rear, or else you're going to have to start figuring spring rate here and spring rate here when you want to roll your car. Another thing I wanted to talk about is J-bars. I don't like J-bars for side lateral locating links in cars. I think there's too many problems with, and I think I've talked about this earlier in the video. But I do like the fact that they give a lot of traction. So let me explain a little something to you about J-bars. First of all, let's say we have a center of gravity in your car. Let's say it's right about here. In late models that I've tested, the center of gravity is around camshaft height, around oil pump height, and it's placed right around the shifters usually. You don't really need to know where the exact center of gravity is. Just take it as a rule of thumb of around oil pump or camshaft height. What I don't like, now let's draw a J-bar in here. Let's say that's the center of gravity, then you got your pinion, and then you'll have your J-bars somewhere over here, and they'll go up and mount on the frame. What happens with a J-bar is it actually wants to lift the car. That's why I always recommended on late model cars to put your J-bar starting point 2.5, 2 inches below the center of gravity, your camshaft height. For that first 2.5 inches, now let's back up a second. Let's pretend you have a rope hooked on your center of gravity, and you got a big strong guy over there, and he's going to pull that rope because that's the center of gravity. It's a little more complicated, but this is the way I see J-bars kind of working in the car. And this is from a pure kinematic standpoint. Now, softness of springs, there's a lot, weight placement, there's a lot that goes into this. But just kinematically with a J-bar on a car, let's say your strong guy is pulling on the car, and it's going to try to pull the car because it's going to pivot here. It's going to try to pick this up and pull this car down, and the car is going to try to roll. Once this point, I believe, gets level with your J-bar, what actually happens is it actually tries to pick the whole car up like a pole vaulter. So you're actually trying to lift the entire car up. Instead of just rolling the car, the whole car will raise up. And I think that's what's unseating our right rear springs a lot, is because guys get a lot of J-bar in there, and then we're getting so much drop on the left rear now that this point on your J-bar gets so far above the center of gravity mount that you're actually trying to lift the whole back side of the car. I've seen a couple drivers lately that have been getting their cars tucked down on the right rear, and I don't know what they're doing, but I think for years I've watched this be a continual problem with some people. And that's where we're running into a problem with these load machines too. People load these springs and, oh, that's what I'm getting for a load. There's more than just that load number that machine's giving you that's going on in your car. And you got to be aware of this type of thing, so you don't run into problems. And you're not misunderstanding what that load machine actually does and where those load numbers are coming from. You have to keep an eye on the kinematics and the weight balance and all the basics first before you really get relying on wheel load. Okay, this is what I do like about J-bars. Let's look at a J-bar from a front here. Let's say you have your bottom mounting point, maybe you have your pinion somewhere around that point, maybe this is a little lower, whatever it is. And then you have it, we're looking at this from the front view. So then you have your J-bar going up over the top and connecting to your frame. Now your axles are here, and your axle wants to rotate the opposite way that your tire rotates. If your tire rotates downward like this, your axle wants to rotate upward and rotate towards the back. That's why pull rods, lift bars, and everything work like they work, because it's counteracting the natural force of the rear end wanting to go up, and it's pushing the rear end back down into the track. Now you have your lower point here below this center line of your axle, and you have this. This is your, what would be your actual planar bar. This should be on this line. When your axle rotates up, this bottom portion, because it is below axle center line, is actually trying to push the rear end up, and actually, almost like a lift bar, it's trying to push traction into your car. If you look at the rear end from the side view, let's say your panhard bar's here, and then you have your frame height over here. Maybe you have your center line and your axle someplace in here, and then you'd have like a lift bar or something here, right? Lift bar wants to push up. Well, the same thing is happening on the front side of your pinion, especially when you get your extreme J-bar angles where those cars are really hiking up. Now you're getting J-bar angles that are way up there. What it's actually trying to do is it's actually pushing up on the chassis and then counteracting. It's acting almost like a short little lift bar, and it'll run in conjunction with this. But the beauty part of the J-bar is it's pushing up on the left rear, so you're not always using all that traction in there to lift your car on the bars. If you get a little bit of shove on your J-bar and you have run a soft spring here. That's why I was talking to the Integra guys years and years ago, and they were getting to the point where as soft as you could run this in shock and even in spring, the more traction they were getting. And I honestly believe it was because you are putting more traction through your J-bar. You are allowing your lift bar to run up more. You could get your car to roll better, but then almost like a pull rod in the rear end, the car was getting traction through your J-bar. That's another place that I think traction is a big thing. That's why I love J-bars more than the lateral locating device. I think there's better lateral locating devices. Unfortunately, our rules now on late models are so locked down. It's like we're running IROC cars, and I don't think there's really any room left to experiment with this stuff. But I think as a lateral locating link, J-bars are okay. They're not perfect. There's better out there. But as a forward traction device, I think that's where J-bars really shine. If you like this video, subscribe to the channel down below, and you can ring the bell for updates. When I put a new video up, it'll give you a notification. If you like the content here, I have a blog at hogantechnologies.com. I can be found on Twitter and Facebook. I have a book for sale. The links are all down in the description below for everything. So if you like it, subscribe, and we'll see you in the next video.